In these next videos, we are going to talk about limits of functions, how to find limits, what we mean by a limit, and so forth. Limits are our basis for calculus, and there's 4 different things that we're going to look at when we talk about methods for finding limits. First is graphically, and that just means we're going to look at graphs of functions and visually see where the limit is going. Numerically, which just means we're going to actually use values of the function to determine what the limit is. Analytically, which means we're going to use algebraic methods to find the values of limits. And then last, there's the definition. So there's an actual formula for figuring out what the limit of a function is. So let's look at what this means intuitively. Okay? So if I have a generic function f of x, and I have some point A, somewhere in the domain of the function, then what I mean by finding the limit is to look from every direction I can around A and determine what the function value is doing as it approaches the x-coordinate that I'm looking at. Okay, so for example, in this case I have basically 2 directions I can look at it since I'm looking at a 2-variable function, or function f of x equaling y. If I pick an x on this side of A, then we see as my x's approach A, or as my x values get closer and closer to A, the function value is going to increase to some point along the curve. Likewise, if I pick an x on the other side of A and look at the values as my x's approach A from this side, we can see that in this picture my function values are going to decrease to some point along the curve. And so once we find that point that both values are approaching, we can call that our limit. And the way we denote this kind of intuitive definition of a limit is that the limit as x approaches A of our function is going to equal L. And so in general, how we use that with limits is we think about we look at taking any function and a point. And when we say the tangent line on the curve, what we're thinking is kind of the same idea as what we did with the limit. If I start at some point x that's not equal to A, and again it doesn't matter what side it's on, but for this picture I'll do it to the right, then we say we look at the point f at x, and we're looking at the point f at A, and we want to find the line segment between them. And the idea of the tangent line is if I think about taking this limit as x approaches A, well then obviously the line segment between the 2 points is going to change. So for example, if I just move it a little bit, then we can see the line segment has moved a little bit more to the left. Okay? And we can keep doing this. So I can keep moving it closer to A, and we see the steepness or the slope of the line segment is going to change with each movement. And eventually what's going to happen is we're going to get infinitely close to that value A. So again, if we think of this limit, we're going to eventually move so we're at that precise point. And what happens there is then we get what we call our tangent line. Okay? It's going to be that line segment that goes through that single point. And so limits, again, we'll use not only to look at values of function, but we'll also use it to determine these tangent lines and look at slopes of the curve at a particular function. And so we have a little bit more work to do before we get there. But that's basically what we're going to be using our limits for both in this chapter and in the next.